Welcome to the Building Savvy Bottom Line. I'm your host, Beverly Smirnis. Our bottom line goal is to ensure that building or remodeling a home is a seamless and enjoyable process, helping builders and their customers better understand each other's challenges, expectations, and industry norms. This episode is brought to you by The Ultimate Guide to Buying and Building in Texas, an online course for Texas newbies or anyone making their first home purchase in Texas. To learn more, visit buildingsavvy.com. I want to welcome to the studio today Jay Connor and his daughter, Olivia Connor Garcia. They have done 1 million borings in the soil to test soils, and they have designed and engineered over 500,000 foundations in Texas. So I've asked them to come on today to talk about foundations and all the work that goes into designing and planning a foundation in the great state of Texas.
Okay, so yeah, I've been doing this for 40 years. This is my 40th year. Started in 1984 as a draftsman and just needed a job. I wanted to be an architect. I wanted to work with houses, but the economy was bad. So I hired on with an engineering company in Austin. I was a draftsman drawing foundation plans for volume builders and custom builders and light commercial projects, small shopping centers, restaurants, some car dealerships, things like that. Then I ventured off, continued doing that, but also wanted to do inspections for the company. And then the economy died in the late 80s, and I had to figure out how to go out, bring work back in the door, which was almost impossible back then because the economy was dead. So it forced me to learn a lot about what's going on. I didn't want it to be one dimensional. I wanted to know the soils, the foundations, the structure, the running of the business, the selling, bringing work in the door, customer service, admin, everything. So just went up through the ranks, became one of the owners of the company 30 years ago, 35 years ago. So after, I'd say, a pretty decent career designing foundations for builders all over the state of Texas, at my age, I said, let's slow down. Let's start handing the batons off to other people, one of which is my daughter, Olivia.
So now I want to ask Olivia. Olivia has her engineering degree. Tell us about your degree and what you did to prepare yourself for the role that you now fill at these companies.
So I graduated from Texas A&M in 2017 with my civil engineering degree. I kind of had my path laid out for me through my dad, which was great to know exactly where I was going, what I was doing. So it was made it easier to absorb a lot of the information and be able to apply it into our industry, residential industry and home building, foundation and framing design. I knew what I was going to be doing with it, so it made it easier to learn and understand everything when I was there. Now I've been able to do some foundation design, framing design, and also forensic evaluations of these foundations. When we see movement, we can do a foundation performance evaluation, and we learn so much from how the foundation is performing when we're designing to code and to acceptable standards. When we wrote the textbook on how to design foundations on these expansive soils, and we still have some issues now and then. A homeowner sees some distress, which is expected in some design. We get to go out, look at it, figure out what's going on, and learn from it, and then apply it to our other designs and review our processes and all of that, and then help the industry as a whole learn from what's going on in the real world on these real expansive Texas soils and really perfect and improve on our foundation design and structural design in general.
We need more young people in the industry. I know we have a labor shortage, and I think it's interesting that, women only still make up about 10% of the professionals in the industry. And so I'm really glad to see you in the position that you're in, and we need more Olivias out there. So I
Yes.
appreciate you.
I was surprised to hear that statistic that it's so low because my graduating class in civil engineering was over 50% women. So I thought that was the standard, and I got out here into the industry, which I've grown up in this industry. Of course, my dad's been doing it for 40 years, so this was my childhood, and listening to him for 30 years has been amazing, valuable insight, priceless to have that history in the industry, but then still getting into the real workforce and interacting with these builders and other engineers and the very different dynamic than I think my dad dealt with coming up through the ranks in the industry. So it's always interesting, and you kind of find and grab onto those other women in the industry and feed off of each other and support each other. Join women organizations in construction. So I'm in Professional Women in Building through the HBA, which is growing into a huge organization for all women within construction, and it's really, really great. Yeah.
Oh. So, what do you do when your soil test tells you you've got a lot of soil to deal with here, or you've got soil and rock to deal with, maybe?
Yes. So the first part, the most important step is identifying those soils where it's easy to say, oh, we have a lot of highly expansive clay in this area. We'll just design for that on all of these lots. But you don't know that that's the case. Like you said, you can have a rock formation right next to a highly expansive clay formation. And if you're designing a house on both, you're going to have some real issues. So you have to have soils information on each site so you know exactly what you're building on is the most important step. So then once we are confident in the soils and identifying what's actually there, then we can go back to our design processes that have been established through our founders and through the highly respected engineers that have come through MLAW. We wrote the textbook on slab on grade foundation design on expansive soils. We wrote the WRI manual, which is conventional reinforcing, was written by one of the other founders, Walter Snowden.
PE.
He was.
So just to give you a background, the roots of our company go back 60 years to 1964. Walter Snowden and Kirby Meyer founded the company together. They parted ways in 1980. Walter Snowden published the WRI manual in 1981, but on the cover, the preface says this is based on our previous 15 years of experience designing foundations. The year before that, Dr. Litton wrote the post-tension manual for the Post-Tension Institute out of Phoenix.
What is post tensioning? Describe what that does and how it's built into the foundation.
You have basically two types of reinforcing in a concrete slab, because without the reinforcing, concrete is just concrete. It's got certain strengths like compressive, but doesn't have tensile strength until you put that steel in there. The rebar is a passive form of reinforcing. Everybody's seen the rebar that goes in there, and it's kind of like the skeleton of your body, and it's there if it's needed. If the foundation starts moving up or down, or loss of support, or the soil's heaving, that rebar will help hold it intact the same way your bone structure does your body. Cables, half-inch diameter cables that run from one end of the foundation to the other. It's what we call a more dynamic form of reinforcing. You put 30,000 pounds of load or force on the cables, you stress them, you stretch them, and it kind of holds that whole slab together. A good analogy would be if you had a whole bunch of dominoes in front of you and I said, push on them and pick them all up at the same time. You can do that. You squeeze the two on the end and move it however you want. Cable is the same way. So we call it cable slabs or post-tension. It's the same thing. Some builders are afraid of post-tension foundations because they've heard that they just don't work. And I'm very quick to correct them and say, no, 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 they weren't designed properly. That's probably why they didn't work. Probably for every failed post-tension foundation, you have a failed rebar slab as well. People just, it's not as noteworthy to talk about it. There are, I would say 95% of volume built homes are post-tension. It's cheaper than rebar. That cost varies depending on the builder, his supplier, his foundation sub, how they negotiate all their pricing. If you're going to build just one or two houses out in the middle of nowhere, you probably just want to go rebar instead of having to tote the cables out there and then go back. And to properly install a post-tension foundation, an extra step is involved, and that is where you stress the cables about a week after concrete placement. After that concrete is set up, you want to then put the stress on the cables, and then you're good to go. I'm guessing our company has designed 300,000 of them. If they didn't work, I'd be first in line to tell you stay away from them. If they're done properly, they're just as good. Other question people say, which is better, rebar or post tension? Well, if you just flat out don't want to do post tension, then I'm going to tell you rebar is better. But if they're designed the same, if they're designed correctly, they should perform the same and it shouldn't matter.
What about foundation piers? Do you sometimes recommend piers, and would you use piers in addition to the post tension or
I personally don't like piers. Piers are expensive. I see piers used a lot on sites where they're not needed, where it just makes everybody feel better, like belt and suspenders approach. Why would you have the piers? Now, if you've got a whole bunch of fill, really bad fill material that's been put there, construction materials or brush and debris, maybe you do need piers. But when you've got expansive soil and you want to put a slab on piers, one of the things we see some people do is they don't take the piers deep enough through that bad clay. But then you also have to be careful because even though you put the slab on piers, the clay is still there and it can still push up and down. It can still move that foundation. So if the clay heaves, it can lift the foundation right up off the piers. And you could tie the slab to the piers, but I wouldn't recommend that if you expect that clay to heave. Some builders will go in and do remove and replace. So they'll go in and dig out massive amounts of soil, the expansive soil, and bring in better material. Take out 5 feet of the clay and bring back 6 feet of better material, low PI, low plasticity, non-expansive fill material. But then you still have a fill situation and you could create the bathtub effect. So there's other problems. MLAW's approach and opinion and policy for the past 40 years that I've been there is overall nothing beats concrete and steel. Bigger, heavier foundation that can withstand the movement, hopefully. And unfortunately, none of them are completely bulletproof. And what we've also discovered when you do take the concrete and steel approach, quite often the reason for the movement, or hesitate to say failure, because a lot of times slabs move, bend, flex like they're designed to do, and people identify that as failure. It's not failure, it's just moving with the soil. And the soils report probably said it was going to move. We probably said, or the engineer probably said in their design when they gave them that, you can expect some movement. It was designed for 2 inches of PVR or this or that. But anyway, you want to jump in there, Olivia?
We've looked at hundreds of these foundations that have suspected failure. They have distress in the home because it's moving with the soil. So we go out and we evaluate the foundation. We take elevation points, map the contours of that foundation, see how it's moving, identify the cracking or distress in the house. And I'd say it's not a foundation issue and it's not a failure in any sense of the word. It is performing well within tolerances that we design for and are allowed. And this goes for a lot of engineers, not just our foundations.
so when you say that there's a certain amount of acceptable movement that's and it's planned for, what should the home buyer expect? Are they're just going to have some minor cracks in the walls that have to be repaired, or what's the extent of that? What's normal?
Well, you never want to see cracking in the sheetrock. A lot of times when we see cracking in the sheetrock, it's thermal. It might be on the south or west side of the house and it just heats up more there. You got to remember when you're building a house, how many different materials do you have that are coming together? Stone and sheetrock, and the stone or brick masonry in the summer on the south and west side of the house, that can get up to like 140, 150 degrees surface temperature, and you're butting it up to a sheetrock wall that's in air conditioning, and it's at 65 degrees. And in between that is some wood and some insulation. And then you got corners, you got materials butting together, and something's going to give. And then there's a question of, is your house, how was it framed? Is it a 1-story house or is it a 2-story house? Are they trusses? If it's a 1-story house and you're building on expansive soils, so the truss would span from exterior wall to exterior wall, and it's basically floating on top of the interior walls. And as the outside of the foundation lifts or drops, those trusses move with it, and it can lift the trusses up off the interior walls. So you get cracking. Most builders know how to deal with that stuff with truss clips or various other things. But typically, you definitely don't want to see cracking in your sheetrock at all. Now, You do see cracking in masonry that may or may not be tied to foundation movement. You do see cracking in your foundations. A lot of times, very common. Oh my God, what's the percentage of houses with corners falling? And people call us out or call the builder out and say, "Hey, I got a problem here. My foundation's failing." How many times somebody thinks the soil report is bad or that the design engineer didn't design the foundation right? And it turns out to be a constructability issue. Somebody did something a little bit wrong because there's so many moving parts, there's so many parts and pieces and facets. Was it 110 degrees outside when they poured the slab? What was the timing of the trucks, the concrete trucks, when they showed up? Did a cold joint form because there was a delay in getting the trucks there? Did they have the finishing crew there? Were there enough people? So you can get shrinkage cracking if they add too much water to the concrete mix because the water starts migrating to the top and or dries out at the top of that 4-inch thick slab much quicker than it dries out at the bottom of the slab, and it starts cracking and it wants to curl up and do various things. There are so many things that go on. It is amazing how many times it's water related, either on the performance of the foundation, the maintenance of the foundation. If the slab cracked, they put too much water in it. The amount of water we put in a slab, when you see a slab being poured, if it's straight out of a truck, it's got way more water than it needs for its structural makeup, its chemical bond and everything. That's why pumping concrete can be a little better because you can put it right where you want it and there's less tendency to overwater it. Too much water is not good because you have all that water in the mix. Water slowly goes away. Depending on the thickness and certain conditions, it can take years for all the water to go away. And as the water bakes out, if you will, the concrete gets more and more brittle. So old concrete is very hard, but it's getting drier and drier and more brittle. That's why sidewalks and driveways crack up so much. It's just flat work. There's not as much to it. They don't put as much reinforcement in there to hold it together. And by the way, your structural engineer has nothing to do with your driveway. A little plug there. You want to add to that, Olivia?
It's a lot of the construction issues, lack of construction oversight, where the engineer might not be allowed the proper inspections that they want to ensure that the foundation was built according to plans. And then it's difficult to go back and make sure that what's on site is actually what the engineer spec'd.
It's an imperfect process. But let's talk about like when something goes wrong. Tell me about your role in that capacity.
So first off, if something goes wrong with a house, it's already gone wrong. Okay. We're being called out after the fact. And it could be typical scenario, homeowner identifies the problem. Some homeowners don't notice it at first. Some are very savvy, very alert to watching everything. Others, they're busy. They're living their lives. It's, oh, I never even noticed that. Okay. Then they call the builder and we need you to come look at this. The builder comes and looks at it. Volume builder, it's going to be his superintendent or his warranty guy. Then we get called in and it's like investigating a car wreck. I mean, it's happened. We can't go back and prevent the car wreck. First, it's just observe and take notes. What do we have? Oh, well, we have cracking here. Okay, is it interior, exterior? We are called out by the builder, not the homeowner. We may have never met the homeowner. We do not know who they are. My guys, my inspectors, anybody that goes out to a project site, they're under orders to observe, take notes, and leave. We don't want you to say something that may confuse the homeowner or concern the homeowner. So just observe and take notes. Even Olivia, professional engineer, she goes out, kind of it's the same way. Let me observe it, water level, photographs, document, measure, and keyword there, document, and go back, let her look at all of it and kind of make an assessment there. Then report to the builder because that's who we have our contract with. That's who we work for. But I want to assure people we want to solve the problem. Our goal is to solve the problem. And if it's, hey, Mr. Builder, you're going to have to replace this or this has to happen, it has to happen. But that's now between the builder and the homeowner, and we're just hired guns as far as that goes. We want it to be done right.
We are design engineers, but with that comes the forensic piece where if there is an issue, the homeowner or builder identifies an issue after the fact that they're concerned about. We then go on a fact finding mission. We'll go out and evaluate this slab and find out what's going on to the best of our ability. What are the facts? What's here? What can we know about the construction process? Everything that went on during construction. Do a little research on the homeowner if we're there and just meeting them for the first time. It does go into it. So while we don't know the homeowner and it shouldn't be a part, it is the lifestyle of the homeowner can affect the foundation. It can affect the performance of the house, where if something is wear and tear by the homeowner and they're misidentifying it as a foundation issue, we can identify that and say, no, this is not a structural concern. This is wear and tear from the homeowner and lifestyle and things like that. So we go on a fact-finding mission to see what's actually going on. Unbiased, yes, this is our foundation, but we are concerned about the performance itself. And we will verify the design, we will verify all of the aspects that we can. And then that information goes directly to the builder, because that is our contract, like you said. After we report to the builder, it's their responsibility to convey all of that to the homeowner. We are not allowed to tell the homeowner anything because we do not have a contract with them. As the design engineer, the homeowner is always free to get their own third-party engineer, do their own forensic evaluation, and we should come to the same conclusion if we're doing the same unbiased evaluation. But there is some engineering judgment that goes there and experience and all of that. So it is a big part of evaluating a foundation. There's a lot of guidelines for how to do it. It's pretty clear cut what you're evaluating, how you're evaluating it, but the decisions at the end can be subjective. And so that's what we're working on as an industry, as forensic engineers, as design engineers, going back and forth with the committees, the national organizations that are standardizing these procedures for evaluating foundations. It's a difficult work in progress because there are so many moving pieces, like we said.
Industry standards you have to acknowledge and adhere to, just like doctors in malpractice. Did they run the right tests before they made a decision?
Well, I think bottom line here is make sure that you're using a builder that hires someone like this team to do the soil test, then engineer the foundation accordingly, and has the oversight to make sure that what you specify is actually what is done at the concrete pouring of the slab. And then if something does go wrong, all you can do is the very best preparation for it, to prevent something from going wrong. But then if it does, you have a system that was engineered to tolerate a certain level of movement, and then you go from there.
Well, you just hit on something. It's really kind of a difficult game. On a typical house, we could way over design it, but they couldn't afford it. That foundation would be too expensive for that level of home price. That's the belt and suspenders and way overdoing it. So you're looking for that sweet spot. So you got to get a good soils report. Helps to have a lot of experience doing this stuff on how foundations move. If somebody says to me, well, Jay, y'all just over design everything. You're welcome. Yes, we do. Do you want us to under design it? They go, well, no. I said, okay. Well, so do you want my team to perfectly design this foundation for this house? Well, yeah, that's what I want is perfection. Okay. Maybe you want to go somewhere else. Number one, and they'll promise you a perfect design. Number two, the pursuit of that perfect design will cost tens of thousands of dollars, where in reality, you're paying us under $1,000. The risk reward on this whole process is horrible. The liability that we have out there. You're trying to find that sweet spot. You want to barely over design that foundation. If you follow the soils report, if you follow the design recommendations, the programs that you're supposed to test run, and you say everything passed, it's all good. It has a factor of whatever over design baked into it. That would be the understanding. And hopefully it's going to work. Then what happens 9 times out of 10, and I'm not picking on anybody, but the homeowner proceeds to mess up the drainage characteristics of that site. So The home builder says, let's get a soils report. We get a soils report. A good foundation design in response to the recommendations of that report. Make sure you're in compliance with PTI or WRI or whatever you're doing. And then the builder builds the slab. You do your inspections. The builder makes sure they have proper reveal around the foundation, a minimum of 4 inches or whatever you're trying to adhere to, and have your proper protective back slope. And if it's in a subdivision, you go to the swale between the two houses and then you carry that out. You drain that out. That's the way it's supposed to happen. The builder delivers that, and then things happen over the next few years. The homeowner builds a new planter, or they put in a bunch of trees too close to the foundation. They put in a water feature. They put in a swimming pool, a hot tub, and then understand when we're talking about all this good drainage, part of your house is covered with a driveway, and part of your house is covered with a big patio. And then the other parts of your house are open soil and the water can just get in. Now, how expansive is the clay? Did they use gutters? Did they use them properly? Did they use proper downspouts? Did they carry that water away? There's just so many things. Do they have a dog? How big is that dog? Who cares? Well, does he like to dig? Does he like to dig right next to the foundation? Lots and lots of variables, moving parts, and the builder gets blamed. The engineers get blamed. The homeowners are frustrated. And so let me throw some numbers out. In the United States, on average, 1.5 million homes are constructed. Now, we need 2 to 3 million houses a year in the United States. I think this year we're in the 800,000 range. We are way off. The home building industry has been off. Different companies, depending on what kind of builders you work with, different engineering companies, their work is off anywhere from 50 to 75%. It's really bad. What does that mean? Well, we have a ridiculous backlog. It's going to get really, really busy. Let's see these interest rates come down. Some things have changed. Just had an election. I don't know if anybody heard about that. But the insanity that I'm talking about is that we do the same thing over and over. And I said, well, wait a minute. What's the number one common aspect of this whole thing? Water. Water is making the foundations move incorrectly. Bend, flex, distort, edge lift, center lift, tilt. That's driven by water most of the time. Even if you have a settlement issue on non-expansive soils, it could have been washed out or underridden by water to help cause that problem. Homeowners, do they have sprinklers? Did they use the sprinklers properly? Did they overwater? Do they underwater? You have a wet side of the house and a dry side of the house. You have sun, you have trees, breezes, fences, obstructing drainage, so many different things. Water says, I can get in here, but I can't get in over here. So I'm going to heave this part of the foundation. So after talking with foundation repair companies, after talking with my engineering team, the forensic engineers that I know, the soils engineers I know that I work with, I said, we could use water to fight water. You use fire to fight fire. Let's use water. So I set out about 10, 15 years ago with a gentleman, and he had an idea, which we modified, ran with it, and we developed this system called Smart Slab. Smart Slab employs a system called aquadation. We are now patented in the United States, Europe, and Canada. The builders that I've shown this to, it's wow. So simple, low tech. So essentially what it is, we have sensors placed strategically around the foundation, not outside. It's protected. It monitors the movement. Those sensors then talk to a control box that looks just like the sprinkler box on the wall in your garage. This isn't incredible new technology. That talks to the valves, and it can open and close the valves, not just around the perimeter of the foundation, but we pre-pipe basic water pipes under the foundation during construction, and then it can wet up the soil under there where it's not getting water to counteract the other areas where it's getting too much water. And I've met with several engineers, the engineering team at Texas A&M about this. I've conferred with Dr. Linton for many years. Olivia has been living this for a few years now with me. The most common response I'm getting from builders is, well, we have to do this. This is good, cheap insurance. This is great. One of the biggest name foundation repair companies has invested with me because they saw the potential on this, that this is a market disruptor. You want to add to that, Olivia?
Just emphasizing that you can detect this movement before you see any cracking is the goal. So the homeowner never even has to be aware that they have foundation movement because it's proactively moving the foundation back toward level. So even the slightest little bit of movement can be corrected, and it never gets that bend and flex that we're seeing that causes the cracking.
Hopefully never does.
Hopefully, yes. Yeah.
Yeah, nothing's perfect, but some insurance companies, the big ones that warrant these homes, I signed non-disclosure, so I can't divulge a lot of this stuff, but they've run scenarios where if it works, let's talk about that for a second. These warranty companies, the big names, once they get it, it's a claim. It's technically a failed slab at that point, whether it really is or not. And so what I've done is I've met with them and shown them we can bring this slab back. Hopefully, that's the theory. Show them how we do it. And they go, yeah, I think you probably can. Get it back within tolerances, get it to correct, versus picking up the phone, calling a traditional foundation repair company and spending $50,000 to $100,000.
On a temporary repair.
Most foundation repair companies will tell you, sure, yeah, they've got to go back out and tweak that thing after 3 to 5 years. I use 3 to 5 years. That seems to be the cycle of weather patterns. In Texas, we have drought and we have floods. And if you have drought for a while, that's one thing. If you have floods and wet period for a while, that's another thing. But when you have those two extremes back to back in the same season, the same year, which usually seems to happen within 3 to 5 years, that's where you see a spike in foundation movement. And so if you see a foundation moving, it's not just, okay, your foundation moved. How did it move? Well, we found out that it's edge lift, so kind of a bowl shape. Well, why? Well, look at all the rain we just had. So all that clay heaved. Well, that water got in around the perimeter of the foundation first, obviously, and it hasn't migrated all the way to the interior of the foundation. And they do calculations. One's called the E sub M, edge moisture variation, in feet. So they say, okay, well, on this soil, that moisture is going to migrate under that foundation 8 feet or 9 feet. Okay, well, the slab is 45 feet across. So there's this zone under the middle of that foundation that's not going to get that water. So as the exterior of the foundation wets up, our sensors would pick up that movement and also pick up the fact that the interior is not coming up. And we say, well, let's start administering water to the interior portions and try to bring it up at the same time. And then if somebody freaks out, if we go out and a homeowner's upset because it has lifted, and I'm talking about existing houses that we don't have smart slab on, what Olivia was talking about earlier, you go out there, you photograph, you water level, you document everything. And then what we tell people, don't pick up the phone and call a foundation repair company just yet. We're not anti-foundation repair companies, not saying that at all. We're just saying, let's sit on this a minute. Let's monitor this. Now that we have a benchmark, now that we've photographed, we've documented where the cracks are, we've measured them, let's wait. And let's come back in 6 months because we're about to go into the summer. Let's see how it looks at the end of the summer. Maybe it's come back down. Maybe some of those cracks have closed up. And that can tell us a lot. Okay, we've confirmed it is drainage. It'd be a lot easier to install. You can even do the system I'm talking about, Smart Slab, after the fact. It's much more beneficial if you install it during new construction. And full disclosure, we've got one full installation already been done a few months ago. We're now working on getting our next installation going. I'm building this thing up. Like I said, we're patented. We meet with the patent attorneys all the time. We're patented in Europe, which means France, Germany, United Kingdom. We're looking at Australia and Hong Kong. Everybody that sees this is just enamored with it. It's like it's too simple. It makes too much sense. Am I saying that it's perfect, that it's foolproof? Absolutely not. I would never say that about anything, but it's good, cheap insurance. If you're building a $500,000 house, a $700,000 house, and I say, hey, we can get this system, get your house at the very least pre-piped. It's just cheap piping we put in there with a little manifold and a little box sitting there. You won't even know it's there. You can do all that for about 2 grand, $2,000 to $3,000. That's pretty good, cheap insurance versus what's going to happen because the drainage characteristics of that house will get compromised. They will get messed up. They don't want to mess up their drainage. It happens. Living, like she said, lifestyle.
Over time, it erodes away, it migrates down the hill, which was put in place on purpose, and it will change over time. And you can go back and do some follow up landscaping and place the back slope back again, but you still don't have access to that zone under the foundation that is not going to perform the same as the edges of the foundation. So, no matter how well the foundation is designed and performs, it's still going to have different movements on the outside of the foundation and the inside. So, this gives you that access and that control over having the whole foundation perform in unison, which doesn't currently exist.
There's naysayers on everything, anything. So any other engineers out there, any other folks that hear this and have heard about it, they may not be completely on board. The main reason is because it wasn't their idea. I mean, it's true. Most people that really look at this thing, and we have a 2-minute video, we have a website, of course, we have a 2-minute video. We're going to have a booth at the World of Concrete in January,
Mm-hmm.
and we're going to have a booth at the International Builder Show in February. Is this right?
Mm-hmm. Yes.
I've met with people over the past 6 months to a year, and I'm not talking about just one person, but they've heard this and they've seen the video. It's pretty well done. And I had one guy, he said, I wish you had never shown me that video. He says, I'm obsessed by that. It's all I can think of. What an incredible idea. That is amazing. Another gentleman that wants to install these for me all over the United States. We're starting right here in Bryan College Station. The word's going to get out. Builders are slow to make a change. I get that. They're slow to put something in, but you can do this in phases. You can just, like I said before, you can pre-pipe. The pre-piping, it's not live. It's not attached or connected to the water, so it can't do any harm. It's just there in case you need it. And I'm telling you what, and of course I'm biased, but if I was a builder, it is a no-brainer. I would put these pipes in. I would pre-pipe my slab in a heartbeat. Rather have it and not need it than need it and not have it. Mic drop. And we're working on some other stuff. I have a thing called V-forms that's also patented that can revolutionize the way you make V-shaped beams for suspended slabs and just to help foundations perform better. So we're talking to manufacturers right now about getting that going as well, called V-forms.
Exciting new technology to help mitigate the problems that are just there with Texas soils.
Yeah, this can be used nationwide. Oh, we've got our provisional patent on the same technology, but using airbags. And that could be used on any slab on ground foundation in the United States or wherever else that we patent that.
So would airbags work by drying out the soil, whereas the pipes add water? No.
No, I wish.
Yeah.
I wish. Beverly, if somebody can really think of a way to draw the moisture out of the soil under a foundation, you would be in Elon Musk
Oh.
territory.
Yes. Yes. So what you're doing right now with the piping is just trying to keep the moisture level consistent underneath all sections of the slab, every piece of the slab.
Great question. It's not that your soil is wet. That's not the problem. And it's not that your soil is dry. That's not the problem. The problem is the change in moisture from wet to dry or dry to wet, either one. So when you build your house, when they pour the foundation, that soil was probably either wet because we had a rainy period, it was in the spring, or it was dry because they poured it in August, September, and we're in a drought. And so that can help you predict how that foundation may perform over the next 3 to 5 years. If that slab was poured, the ground was dry, it's probably going to heave on the perimeter. And conversely, if you poured it in the spring, it's probably going to drop a little bit. We try to tell people it's okay, it's going to change back. But I get it. Homeowners are like, well, I need to do something about it now. And the cracks you can't reverse. But the thing is, we don't want them to repair the cracks until we've stabilized, till we've removed the undulations, the back and forth. So it's the change in moisture that's causing the problem, not necessarily the moisture itself.
And
Yeah.
to reiterate what we said before, that when a homeowner identifies an issue, the issue being cracking or distress in the home, it doesn't mean that the foundation has failed or has excessive movement. The materials used in construction are so brittle and so sensitive to this movement that even a little bit can show a little distress. So, this is helping to control that movement. It doesn't mean that it's a one time fix because you're still going to have the soil that's moving with those moisture variations. So, it's not a add water, you're done, your home's going to be sedentary for the rest of its life. It still needs monitoring and it still needs adjustments.
When you design a foundation, you are trying to identify and carry the loads, most of which on a typical house are perimeter loads. Some of the interior walls do have some heavy loads if it's a two-story house. All of that you can get in a textbook. You can get that on your computer now. It's all span tables, span charts and load tables and all that stuff. Your live load, your dead load, all that stuff. The trick is all of those materials, most of them are lightweight, glass, sheetrock, various other things, ceramics, the flooring materials. But now you got to design this thing on the ground and you're fighting Mother Nature. And you don't know where Mother Nature is going to push back. That's the biggest challenge of this whole thing. Most builders want to do it the right way, that's for sure. And they get frustrated, and the homeowner gets frustrated, and it's like the structural engineers kind of get the blame for it. And we say, look, we followed everything we're supposed to do. And instead of everybody getting too upset, let's identify, document, and let's keep an eye on it. Let us come back in 6 months to a year and see what happened.
If you have an existing house and you don't want to put pipes underneath the foundation, you can at least install the sensors and be able to monitor the
Yeah.
foundation without having somebody come out every 6 months. We can do it remotely. We can take a look at it and identify some areas on the foundation. Say, hey, this sensor has been picking up a lot of movement. You might want to take a look in this area and see if something's changed. Do you have a leaky hose bib? Do you have a downspout that lost its splash block? If it's depositing all that water right there, you've got to change that it's picking up. And that can be a good first step for getting control of what's going on and identifying these drainage issues.
And one of the most common things we do when we look at a house is walk around the yard, look at the grass where we've got lots of grass. There are parts of the yard where the grass won't even grow anymore because there's too much water. And then there's other parts of the yard that are, the grass is clinging to life because it's not enough water. And then usually if you walk around somebody's yard, you can find at least one sprinkler head that is probably geysering when it's on, but nobody knows. And so it's getting way too much water right there, which means the rest of the sprinkler heads on that station aren't getting the water they need. So then you go into the garage and you check the timing of each station and adjust that and say, sorry, those beautiful bushes that you planted that you're watering the heck out of, they've tweaked your foundation up. You have caused the problem. Sometimes we just flat come out and tell them that. Oh, that swimming pool over that beautiful swimming pool. Notice all this lush green grass over here between the house and the pool? Yeah. Do you fill that pool up a lot? Oh, yeah, I got to run the hose out there and fill it up. The level goes down. Yeah. And notice how the earth slopes towards the house from that pool instead of the other way. You're getting water, probably. We've identified that. Well, what do we do there? Well, identify your leaks coming from your pool. Well, how do you know my pool has a leak? Because it's a pool and it's surrounded with water and pipes. I was dealing with that with mine just yesterday, as a matter of fact. And you might have to put a barrier or something. You can dig a trench and put a fiberglass barrier or fill it with concrete or something just to slow down or stop that flow of moisture. It can be that simple. It doesn't have to be, $100,000 foundation repair. Some of them do. That's just the way it is.
Yeah. Our biggest advice as engineers is consult with an engineer. If you suspect any sort of issue, consult ahead of time, catch it up front. Because in Texas and central Texas, especially with these expansive soils, the soil's going to move, like we said, the moisture is going to fluctuate, and you might have some foundation movement. So catching it up front and being able to make some, even small changes can really affect the performance of the foundation. So don't be afraid to consult with an engineer, have them look at it and identify some of these potentially problem areas and make some small changes. And it saves you a lot on the back end. But if that's not easy to do, identifying drainage issues is not always easy to do. You can have the backup, which is the sensors, and it's monitoring everything for you if you have an existing house and you can't get the pipes underneath it.
These sensors are really cool and really sensitive, and you can even pick up the heat on certain sides of the house. You can pick up that foundation is everything's expanding over there on that corner. And depending on, again, how the house is constructed, you can pick up that movement with those sensors. Apparently, there's another sensor out there in the world. I'm not going to talk about it, but it's not very sensitive at all. It's not accurate down to what you need to pick up foundation movement. And basically, you want your foundation on a house to not move more than 2 inches. Would you say? Throw that number out there. But it depends on the size of the slab and things like that.
Yeah.
I'm just saying if a slab has an inch of movement across it, that's not the end of the world. And
Mm.
that's the other thing. Sometimes they're poured that way. The foundation finishers just didn't get it perfectly level or perfectly flat. It's up and down a little bit. That's why we recommend to builders to get a original construction elevation inspection. We call it an OCE. You go out there. It's kind of the last thing you do before you turn the house over to the new homeowner is get a reading on that foundation. If I was a custom builder, I'd get it like a week after the slab is poured to see what my finisher is giving me. And then I would do it one more time right before closing to see how much it has moved. Like I said, trying to reach that equilibrium on the site. There's post construction movement and see what it's done. Otherwise, they make an assumption of plus or minus 3/4 of an inch, which could mean if the homeowner thinks their slab is moved, and it may have, the engineers are automatically, they're already guilty by 3/4 of an inch of movement that may not have happened. It may have been poured that way. I sound paranoid now. Just cautious. Just cautious.
Well, I just want to thank Jay and Olivia for all the great information. I want to congratulate them on the groundbreaking technology of the Smart Slab. If you want to find out more about that, you go to smartslabsystems.com. And from there, you can contact Jay or Olivia to answer any questions that you have about foundation engineering, soil testing, soils in Texas, all the good stuff that they're involved in. We really
Yeah.
appreciate having you on the Building Savvy Bottom Line.
All right. Thank you, Beverly.
Thank you so much.